Okay, so the next section in calculus that I would like to cover is Chapter 4, which is Extreme Value Unit. This section will cover some coursework for the homework of 3.1 and 3.2. So taking a look at 3.1, that is just starting to look at notation with intervals. So for instance, if I was to look at this graph, and this is question 1 on page 170, if I was to look at this graph and talk about the interval of where we're increasing, we would be increasing when x starts at -5, so this point here, and it increases until x is 0. So my first interval of increasing would be -5 to 0, but then it's also increasing from when x is 2 going to when x is 5. So you use this like union symbol, and then you would write 2 to +5. The other part is asking when x is decreasing, and x would be decreasing when the slope is negative, so from 0 to +2. So we can write that down. So this is just the first part with intervals, and when we are looking at where you are increasing or decreasing, it does have to do with your slope. So for this next one, when we're just given the equation, if it's asked when you're following intervals and when you're increasing, because it has to do with the slope, we know if we take the derivative of your function, so in this case it would be 1 minus 2x, that when the slope is positive, you are increasing. So here, if we start with, we just do want to figure out what x equals. So if I take that 1 minus 2x and set it equal to 0, x will equal 1/2. So those are that's one of the values we'll look at for when we factor it. So if I put 1/2 right in the middle here, and then take a look at my function, 1 minus 2x, and think of values below it and then values above it. Values below it, if I put in anything negative and multiply it by the 2, the -2 would become positive. So our value would always be positive. If I put anything above it, it's going to be negative. So this is telling us in terms of our slope that anything below a half is going to make our slope positive. Anything above a half would make our slope negative. So when I'm writing this in my interval notation, I would say from -infinity to +1/2 for x, my slope will be positive, or I would be increasing. The next one is similar, just a little bit more work to do. Same idea. If we're looking for when we are increasing, we want our slope to be positive. So we want to look at our slope. I don't know why I wrote f when this is g. So g prime of x would equal 3x squared minus 3. I'm going to factor this. So I'll take out a 3, and I have x squared minus 1. And then I'll notice I have a difference of squares. So x plus 1 times x minus 1. So my important values here are going to be when x is -1 and when x is +1. So I would do the same thing, write out my chart, and I have my factors. I would include 3 because that would matter if that coefficient was negative. It would have an effect, but positive wouldn't, but we'll still write it just to be consistent. And then x plus 1 and x minus 1 are my other factors, and then I want to see what happens with my slope. So from there, I would have values below -1, and then between 1 and +1, and then above +1. So below, between, and above. So the value 3, it doesn't matter where we are, it's always positive. The x plus 1, if I plug in values below -1, I'm going to be negative. If I plug in a value between -1 and 1, like 0, I'm going to be positive, and anything larger will be positive. For x minus 1, if I plug in something less than -1, it's -1. Between -1 and 1 will be negative, and above would be positive. So then I have to remember a negative times a negative is a positive. Here it's all negative, and here it's positive. So when I'm looking to see when I'm increasing anytime I'm below -1 and anytime I'm above 1. So to write that out, I would say from -infinity to -1, then do the union. I'm also positive from 1 to +infinity. So that was the first part, and I stopped there for that homework just because if you did continue, the next questions are asking when you're decreasing. So instead of looking for when you're positive, you would be looking for when you're negative. And then the following question is putting both together when you're increasing and decreasing. So I think if you can do the first couple, you're good to go. In section 4.2, it's just adding on some extra terminology. So you hopefully would remember what a maximum or a minimum was. So if you're looking for an absolute maximum or min, you're looking for the entire domain. If you're looking for a local or relative max or min, you are looking for another max or min that's in a restricted domain. And then lastly, a critical number. That is when you're looking for when your derivative is 0 or does not exist. So critical numbers, when you're looking for that, you do have to look for the derivative. This other part though, you don't need the derivative, you're just looking at the function. So if I took a look at my first example here, and this is just from your homework, and I wanted to see what my absolute maximum is. So my absolute max is your highest value possible. So for this function, and I don't think I wrote this function down, but that's okay. My function here, if I plug in the value, and this value would be, so 3, 4, 5, 6, 7. If I plug in the value and x is 7, I get out the number, so over here, 1, 2, 3, 4, 5. I get out the number 5. So that's my absolute max, the highest value of my entire domain. My absolute min is this value down here, so the lowest point on your graph. And that value is when your function plugs in 2, you get out -2. Then we do have a few other points. So if we're looking for a local max or local min, we have this local max up here. And then we do have another local min, and we have this one here. There's a few more we can point out, but it's just asking for us to get one. So we'll just put one. So one of your local max is when your function, you plug in 4, you will get out 3. And another one with a local min, if we plug in -2, we get out 1. So looking at a graph, it's pretty easy, but when we have just a function, it might be a little bit harder, and we'll always want to draw it. So with this one, when it says sketch the function and state your absolute or local max or min with this function g of x when x is greater than or equal to -1. So if I were just to quickly graph this, I would know my y-intercept is -1, but that won't matter because x is starting at -1. So if I looked at g of -1, I would have 3 times -1 minus 1, which would be -4. So let's, when we're at -1, 1, 2, 3, 4, this would be my starting point. And the other part we want to recognize here, oh, this is, what did I do wrong here? Oh, that was fine. So the other part we want to recognize here is that this line, or this equation, is a linear equation. So we do have a straight line. And then when we are talking about it, we don't actually have a max because this graph is going on forever, but we do have a min. So your absolute min is going to be when x is, I keep writing f, but this one's g. When x is -1 and your y value is -4, that will be the only min we have. And then in terms of our graph, it goes on forever. So if we're taking a look at that, that would mean that we have no max and we can just move on. This next one, in question number 3, it's asking for your critical numbers of f of x. So if you're looking at critical numbers, we want to remember you need the derivative. So we're going to take the derivative, and when we do that, we get 3x squared minus 3. And we saw a question similar to this. We're going to just do some factoring, take out a 3, and you have x squared minus 1, which ends up being x minus 1 times x plus 1 because of that difference of squares. So based on this information, your critical numbers are when your factors are equal to 0. So that will happen at x equals 1 and at x equals -1. So whenever you're finding critical numbers, use your derivative, factor, and find your zeros. The last question, I believe, is, oh no, I have 2 more, this question here, finding the absolute this should say max and min of our function. So with this question, and we have this domain 0 to 3, we are just going to take a look and do some graphing. For this, we kind of know already that this is going to be a quadratic equation, but we can take a look at a few more pieces of information. So for instance, if I wanted to take a look at my slopes, I'm going to take my first derivative, and that gives me 4x minus 8. I'll factor, take out a 4, and I have x minus 2. So that tells me I have a critical value or critical number of x equals positive 2. And that is also, that critical number is telling me I have a max or a min. Because this graph is quadratic and opens up, this value is going to be a min. So if I go back to the original function, f of 2, and plug in my value of 2, I will get out negative 7. So we also have a few more important points, and that would be the point the graph starts and end at. So f of 0, plug that in, you get out positive 1. And f of 3, you're going to get out negative 5. So if we go to graph some of this, that first one, f of 0, is positive 1. That's going to be this point right here. So that's where our graph is essentially starting. And then we have our min. So when x is 2, our min was negative 7. 2, 3, 4, 5, 6, 7 was this point here. And then when x is 3, this goes up to 5. So this is our graph right here. It would look nicer, more curved, but you get the idea. And then when we're taking a look at, actually, I think that's all we need. So we have our min point. So this point here is our min. And we have our max point, that top point there. Oh, I messed that up, didn't I? This is, oh, I said this point, but then I pointed to the wrong thing. That is our min. And this one is our max. And this extra point, essentially, we won't worry about right now. Okay, this last one is one I like because I think it does bring in a bit of theory. And so when I've taught this before, I do skip number 5 if you are following along in the textbook. But this one is to find the value of k given the function y equals x squared plus kx plus 72 if you have a local min at x equals 4. So with this question, telling you have a local min, that is telling you essentially that at that point your slope is 0 because you are switching directions. So your slope stops. Why that matters is your slope is a derivative, right? So if we take the prime of, again, this one would be y. If we take y prime, the first derivative, that would be 2x plus k. We can say that 2x plus k equals 0 when x equals 4. So we can plug in 4 here and solve for k. And that makes this nice and easy because then k would equal negative 8. And then the question's done. So as always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I can do for you, whether it's math or chemistry, please leave me a comment. Thank you for watching.